Welcome to The Explainer. Today, we're jumping into something called the Universal Life Protocol, or ULP for short. Now, this is a framework with a really bold promise to help us create software that is perfectly verifiable and totally reproducible every single time. So let's dig in and figure out what that actually means and why it's kind of a big deal.
You know the drill, right? A developer swears up and down, it works on my machine. But for you, for the customer, for everyone else, it just crashes. This age-old problem, this ghost in the machine of unpredictable software and bugs you can never seem to recreate, has been with us forever. But what if we could just get rid of it? For good? Well, the Universal Life Protocol goes right for the heart of that problem. This isn't about fancier logging or another debugging tool. Nope. This is a totally different way to think about how software runs. It's an approach that guarantees, and I mean guarantees, that if a program runs once, it can be run again, anywhere, anytime, and you will get the exact same byte-for-byte result.
And this quote right here, this gets to the absolute core of the ULP philosophy. See, normally a program runs, and it might spit out a log file as a side effect. ULP completely flips that on its head. In this world, the whole point of the execution is to build an authoritative record, something called a trace. And that trace isn't just a history of what happened. It is the machine. It's the ultimate source of truth.
This slide shows that shift perfectly. Over on the left, you've got the old way, where the running program is the thing we trust. But on the right, you see the ULP model. You start with a static world definition. Think of it as the system's rulebook. You give it an input, and together they create a single authoritative trace. That trace becomes the new reality.
Okay, so how on earth does ULP actually build this perfect record? Well, it all comes down to a core engine that is completely deterministic. It leaves absolutely no room for guesswork.
At its heart is this really elegant and simple formula. The yellow circle, the ball, that's the world definition we just talked about. It's the set of rules for the system. When you combine that rulebook with a specific input, the blue triangle, the engine deterministically, meaning predictably, generates a point, that purple star. And that point is the final unchangeable trace. The promise is simple. Same world, same input, you get the exact same result, always. And here's how that process actually works step by step. First, the system calculates a unique identity for the world based on all its rules. Second, it looks at the rules and figures out which inputs or actions are even allowed. Third, the engine runs all those valid actions in a super precise, deterministic order. This execution is what generates the trace, and then finally, a unique ID is calculated for the trace itself. That makes it a verifiable artifact, like a digital fingerprint.
Now, all of this is organized into 4 clean layers. You've got the kernel, which is the heart of it all, the truth engine that makes the traces. Then you have adapters, which are basically tools for comparing different traces to each other. The transport layer, its job is just to move these traces around. And finally, projections are the user interfaces, the windows that let us look at and understand the truth that's locked inside a trace.
Okay, so we can create a perfect, self-contained, auditable record. That's already incredibly powerful. But here's where it gets really interesting. When these perfectly contained systems need to talk to each other. This is the main focus of our explainer today. How do these systems communicate while staying perfectly reproducible and trustworthy?
You see, each ULP system basically creates its own trace universe. Just think of it like a self-contained reality, its own little bubble. It's totally independent, completely deterministic, and it has a perfect, unchangeable history book, its trace. Everything inside is sealed and consistent.
And that brings us to the million-dollar question, right? If your entire system is built on this guarantee of perfect, isolated predictability, how can two of these universes ever interact? How do you possibly let them exchange information without introducing the very chaos and uncertainty you worked so hard to get rid of?
The answer, it turns out, lies in a very specific and strict set of rules for how they exchange information. It's a method that guarantees the integrity of every single universe involved, creating a closed, verifiable loop.
And this slide right here is the absolute key to understanding how it works. On the left is the wrong way to do it, state synchronization. That's where you try to get two live, messy systems to agree on what's happening right now. It's a recipe for disaster. ULP does it the right way, artifact exchange. The universes never share their live changing state. Instead, they exchange these immutable artifacts, these perfect, verifiable pieces of their own history, each with its own unique digital fingerprint.
And this exchange is governed by some very strict safety rules. First, these artifacts are immutable. Once created, they can never be changed. Second, they're processed in a deterministic order, so you always get the same outcome. Third, the system is fail-closed. That means if any invalid artifact shows up, the whole process just stops. No corruption allowed. And finally, no universe can force another one to break its own internal rules.
And by sticking to these rules, ULP actually delivers on that big promise from the beginning. It creates a federation of trace universes that can safely exchange verified artifacts, all inside a closed execution loop. And the result of all this? A massive, interconnected system that is still completely reproducible, totally auditable, and doesn't care what computer it's running on. That right there is the payoff.
So what's the big picture here? Where is all of this heading? Well, this model of federated, verifiable universes points to a fundamentally new kind of digital world.
The grand vision is something the source material calls a deterministic cyberphysical metaverse. I know, it's a mouthful, but the idea is stunning. Imagine a computational fabric where these verified historical artifacts, these traces, are the source code for, well, everything. They could be used to perfectly replay entire worlds, not just in software, but across physical hardware too, with all of it sharing one common, provable ground truth. So I'll leave you with this final thought. In a world that's often filled with digital smoke and mirrors, what actually becomes possible when our digital systems, from our simple apps all the way up to complex metaverses, can exchange provable, verifiable truths as easily as they send an email today? What does that future really look like?